Without further ado, here's Professor Richard Dawkins and Dr. Neil deGrasse Tyson.
Well, Neil, we're here to talk about the poetry of science. I would say that science is the poetry of reality. And one of the things that I feel a bit humble in your presence, biology being a kind of junior science to physics, I suppose we both have something to learn from each other, but I can't help feeling I've got rather more to learn from you than you've got to learn from me. Maybe we're both a bit naive about each other's subject, but I think I'm a bit more naive about yours because there's more to be naive about. I forget who it was, he coined the phrase physics envy.
Yes.
And I think this shows itself in lots of fields, perhaps less so in biology than others. So what we're going to try to do is to have a conversation between a biologist, an evolutionary biologist, and an astrophysicist, a kind of mutual tutorial without a chairman to get in the way. And I thought we might begin by noting that what we can see with our sense organs is an extremely narrow band of what there is to see, and this is particularly so with the visual sense, and we can see a tiny narrow band of the electromagnetic spectrum, the rainbow. But the rainbow's width is tiny compared to the vast expanse of the electromagnetic spectrum. And I see that as a kind of symbol for how limited our understanding of the universe is as well, because after all, we are evolved beings who evolved to understand the interactions between medium-sized objects moving at medium speeds. And this ill-equipped our brains to understand the very small, quantum theory, and the very large, which I suppose is covered by relativity. So I find myself as a mere biologist baffled by some of the things that physicists talk about. And just to throw out one example, in the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. But you started with our sensory organs and landed in the expanding universe. Can I take us back to the organs and then perhaps land in the universe?
Yes.
The urge to think of our senses as being powerful or good is strong because first, that's all we have. Second, we like having nice thoughts about ourselves rather than miserable, depressing thoughts. So we're prone to walk around celebrating, for example, the power of sight or of taste or of smell. When, of course, when you really want to smell something, you bring a dog and they smell. Their nose smells much better than your nose smells. I was going to say the dog smells better than you, but that would insult you. So their nose smells. So we already know that our senses are feeble, and we reach to other creatures in the animal kingdom, cite them as having better examples of our sight, of our taste, of our smell. But little did people know much before a century and a half ago that our sense of vision is limited only, as Richard said, to the colors of the rainbow. And it's quite extraordinary to realize that, for example, beyond red, there's something called infrared. And beyond infrared, there are microwaves. And beyond microwaves, there are radio waves. Go the other direction, you go beyond violet, ultraviolet. Beyond that, X-rays, gamma rays. Energy goes up as you approach gamma rays. With dramatic consequences if you have gamma ray exposure, by the way. Of course, we all know you turn big, green, and ugly, as the Hulk had experienced. But the point is, the visible light part of that spectrum is a tiny slice, and the universe doesn't only communicate with us through that slice, as we had taken for granted for so long. Most of the history of the telescope, which is itself an extension of our eyes, extended the power of our eyes, but not the range of our eyes. And it wasn't until we first understood maybe we're missing something in the 19th century. The 20th century came decade by decade, new telescopes in each newly discovered band of light. And only then did we learn about black holes in the universe, or remarkable, violent forces operating in the centers of galaxies discovered by radio telescopes. So, yeah, we're practically blind out there, and it's humbling, by the way, but that's the whole point of the methods and tools of science, to not only extend your senses in the domain in which you understand, but to take them to places they've never been before. On top of that, we have methods and tools that detect things that are not even extensions of your senses. You have no clue what the magnetic field is around your body right now. You have no clue whether or not you're being bathed in ionizing radiation right now. You'll eventually figure that out as limbs start falling off, but while it's happening, you actually don't know. And there are other things that are more subtle, like polarization of light. So when I think of the scientist's toolkit, especially the astrophysicist's toolkit, it's all about how many different senses can you bring to bear, technological senses can you bring to bear on decoding the universe. One of the things we've discovered, now getting to your horizon question, we look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second, forgive me using miles per second.
I prefer miles.
You do? You got that on tape? You're an Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's why here we have the English breakfast and the continental breakfast.
Yes, that's
They're
right.
very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. Depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. If you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
you want it to be a harder problem than it is. I'm just simply saying, so here you go. Here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here or returned to this spot a billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that
No.
can?
Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point.
Okay.
We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.
Yeah, okay. I just want to make a remark. You drew the analogy of the sense of smell, what a poor sense of smell we have. It's a fascinating fact that although dogs, for example, have a much better sense of smell than we have, as you mentioned.
That's what I say, sense of smell. That's what I should say. Not that dogs smell better, but they have a better sense of smell.
Yes.
Thank you for
but
that.
But we have the genes that would once enabled our ancestors to have as good a sense of smell as dogs. But the genes have mostly been turned off. And so we have vestiges, we have historical relics of those genes. And it's like your hard disk on your computer that's cluttered up with remains of old chapters you've written here and there and things that have now been cut off. Those genes have been turned off, but they're still there.
Isn't that the premise of X-Men?
I don't know.
They're human, but they have a genetically different genes are turned on and off within them, giving them special powers. So are you suggesting the day might arise where we go inside the human genome and flick the dip switches on and off and we come out as Superman?
Put it this way, it's not as unlikely as it might have appeared before we realized that we do have those genes still. You don't have to import the genes from dogs, although the technology of this coming century may enable that to happen.
I'd still rather it be the dog that sniffs the bomb than me.
Yes. Well, we'll probably have robots to do this sniffing. So, what about this point about the difficulty of maybe I chose a too easy an example. The brain. How is it that the human brain, which evolved to do really rather mundane things,
to not get eaten by lions,
to not get eaten by lions in the Pleistocene of Africa, because as you'll learn this evening, we are all Africans. We all come from Africa, and our brains were shaped by natural selection on the African plains to do things that involve objects like this. I mean, medium-sized objects. Macroscopic objects that don't move anywhere near the speed of light. It's a tremendous tribute to our species that we are capable, at least some of us are capable, of understanding things that don't belong on that ordinary macroscopic, slow-moving scale.
Yeah, and so therein is the value to us, not only of the methods and tools of science, but also of the language of the universe that we call mathematics. Remarkable thing, a point first advanced by Eugene Wigner, that math has an unreasonable utility in the universe since we just invented it out of our heads. You don't discover math under a rock, as you might find a Grubbs. You invent it out of whole cloth. Yet, it empowers us to provide accurate and predictive descriptions and understandings of the universe. And so what comes of this is you learn to abandon your senses. And that's a line from the Broadway musical, Phantom of the Opera. Abandon your... never mind. Sorry. So I want to write Broadway lyrics one day in another life. You train yourself to abandon your senses because you recognize how they can fool you into thinking one thing is true that is not. You abandon them. You use your tools that do the measuring to say, okay, that's the reality. Then you make a mathematical model of that you can manipulate logically, because math is all about the logical extension of one point to another, and then you can make new discoveries about the world that, frankly, you'll just have to get used to. No longer do you have the right is not the right word, but no longer do you have no longer are you justified saying that idea in science is not true because it doesn't make sense.
Absolutely. Yeah.
So nobody cares about your senses.
Yes.
Your senses came out, forget the Serengeti, just growing up. As a kid, something's in your hand, you let go of it, it falls. You tip a glass, water spills. You are assembling a rule book for how nature works in the macroscopic world. The microscope takes you smaller than that, the telescope takes you bigger, and other laws of physics manifest themselves in those regimes that you have no life experience reckoning. And so it's math that allows you to take these incremental steps beyond the capacity of your senses and perhaps even the capacity of your mind. Yes, it's the mind that's taking the steps, but your mind was not deducing that by just looking at the world with your senses. It was helped out. It was aided by these tools that we invented.
And at some point, when you get so used to doing the mathematics, it becomes kind of intuitive in rather the way that I'm told that pilots who get used to flying a plane, and they start to feel the wings of the plane as being almost part of their own bodies. They develop an intuitive feeling.
No, so how many is this common? Is this a common sensory perception of pilots?
I think it is. It's a common thing. I think that when people get skilled at using micromanipulators, where they're using their hands, and what's actually going on is tiny little minuscule movements going on under a microscope.
So it becomes their hands.
It becomes their hands.
The plane becomes the pilot.
Exactly.
Or the pilot becomes.
And just
the plane.
as you said, the telescope is an extension of the eyes.
I knew this. My advisor in graduate school, one of my advisors, I spoke to him one morning. He was doing research on star clusters that have these huge orbits around the center of the galaxy. He said he had a dream the night before where he was one of these clusters, and he was orbiting the center of the galaxy. I thought that was so cool.
Yes.
If you start becoming in your cosmic dream, I want to have those dreams, because then you think creatively about what remains to be discovered.
Absolutely. I sometimes wonder about whether surgeons, maybe even surgeons of the present, who are using micromanipulators inside a body. I mean, something like when they stick that thing up you and it goes.
They stick a lot of things up you. Okay. The last I've heard.
And I mean, already you have surgeons driving an endoscope inside and turning left to get round the intestine, turning right. I imagine the time will come when a surgeon will have virtual reality goggles on, and the surgeon will actually feel herself to be inside the body of the patient, and will turn left and will literally walk across the room, and that will be translated into the micromanipulators, the endoscope moving.
This sounds really cool. I like this idea, and you know what you'd have to do? You would have to alter the dominant laws of physics in that regime. Because if you're small enough, a la Fantastic Voyage, the 1960s film, when you're that small, capillary action and surface tension and all manners of other forces take over.
Yes.
And that then becomes your new reality, your new sensory
That's right.
standards.
You would have to become sensitive to surface tension. Darcy Thompson made the point in, I think, 1919, that to world of an insect, gravity is negligible.
Who cares?
What matters is surface tension.
That's right.
And you'd have to be that. I never thought of that. But what I do
That's because you didn't see the movie Bug's Life.
Okay.
In Bug's Life, they serve up a cocktail to an insect that goes up to a bar, and all the bartender does is pour out water from a spigot and hand him the bowl of water. Like that, and the surface. This was brilliant of the cartoonists here,
that'd be very good.
Of the illustrators, and then he sticks a straw into the sphere and sucks it out. No receptacle needed. You got to get out more.
Well, I imagine my surgeon of the future being armed with a virtual, what do you call it, saw, one of those. What are those things you cut trees down with? Bandsaw.
Bandsaws, yeah.
And what's really going on is a tiny little micro scalpel inside, but the surgeon is wielding an axe and is all done by virtual reality.
But I've got a question back to you. So I lose sleep over this, and I've always wanted to be in the company of a leading biologist to get insight into this. As an astrophysicist, we've seen throughout time the hubris that comes with any discovery that gets made, or the hubris that prevents the acceptance of a discovery that might demote your sense of self from whatever you previously imagined it to be. Among them is, where is Earth? Is it the center of all things? No, it's not even a significant planet in orbit around an ordinary star in the corner of a ordinary galaxy, one of 100 billion galaxies in the universe. And so here we are saying, let's search for life in the universe, intelligent life like us. Well, who are we to say that we're intelligent? I mean, I pose that not as a joke question, but it's a very serious question. We define ourselves to be intelligent in ways that no other creature can rival. Okay, now what do we credit that intelligence to? So you look at the genome, and let's take the chimp. I guess that's a really close relative of ours. And we have, high 90s% identical, indistinguishable DNA. And the chimp does not build the Hubble telescope, and the chimp does not compose symphonies. So we must then declare that everything we say about us that is intelligent is found in that 1.5% difference in DNA. Is that a fair statement to make? Okay. Let me invert that question. If the genetic difference between humans and chimps is that small, maybe the difference in our intelligence is also that small. Maybe the difference between stacking boxes and reaching a banana, putting up an umbrella when it rains, whatever are these rudimentary things a chimp does that the primatologists roll them forward and boast about, which of course our toddlers can do, maybe the difference between that and the Hubble telescope is as small as that difference in DNA. Because I pose the question, suppose there was another life form on Earth or elsewhere, that in that same sort of vector, that 1.5% difference we are to chimps, suppose they were 1.5% different from us. They would then roll the smartest of us in front of their humatologists and say, there's Hawking, oh, this one is slightly smarter than the rest of them because he can do astrophysics calculations in his head. Like little Timmy over here.
Yeah.
So I wonder if we're just blithering idiots in the presence of even a trivially smarter species than us. So therefore, who are we to even assert that, number one, we are intelligent and we're looking for others at least as intelligent as us out there to talk to? By the way, is there any other species on Earth that we can talk to? Can we have a conversation with a chimp? That has nearly identical DNA, and I don't think we can actually say, hey, what movie do you want to see tonight? You don't have that conversation with a chimp, yet somehow we believe We want to believe that an alien on another planet that's not even based on DNA, and even if it is, it's not nothing like us, that we could communicate with it.
Yeah.
I'm screaming at you, I'm sorry.
Well, I mean,
so what do you, so there.
Well, I'm all for, yeah, I'm
Are
all
we
for,
as stupid as I'm saying?
I'm all for deflating hubris. But, I mean, it's also true, of course, that our brains are anatomically very, very much bigger than chimps. And so that also is contained, must be contained in some sense in that tiny little percentage of DNA. I think the way to look at the DNA problem is to say that the sort of DNA that has been sequenced and the sort of thing that on which we base that calculation of the 98% is, if you look at again, look at a computer, and you'll find that most of the programs that are written are at the machine code level are calling up the same set of subroutines. There's a subroutine for pulling down menu bars and a subroutine for moving windows and so on. That's what we're looking at in this 98%. What we're not looking at is the set of sort of high-level instructions that say, call this subroutine now call this one, now call this one, now call that one. It's not just humans and chimpanzees. All mammals have pretty much the same repertoire of genetic subroutines. And it's the difference between a man and a mouse, like the difference between a man and a chimpanzee, is the order in which they're called, the sequence in which they're called during embryology, which causes the really quite substantial anatomical differences between a human and a mouse, and the quite big differences in brain size.
If we assume we're not some measure of things, then, as I said earlier, that tells me that the day might come where we could go in, understand which sequences are called in what way, and invent whole new sequences never before dreamt of by biology.
Yep, absolutely.
Empowering us in ways never before
known. Very, very
of.
difficult. It's much more difficult than it sounds, but still, it's in principle possible. But the other point about intelligent life in the universe, never mind how we define intelligence, we're only going to encounter them if they are intelligent enough either to come here, which is very difficult indeed, or to send radio transmissions to us, which is a lot easier, but still requires. Let's just define it as the quality that you need in order to send information across the universe. Now, you don't have to call that intelligence, but whatever it is, that's what it needs in order to get here, in order for us to apprehend it.
And I wonder, surely you've walked past a worm that had just crawled out of the earth, and when you did so, you weren't saying to yourself, gee, I wonder what that worm is thinking. You just simply didn't care. You're so far beyond I don't want to put words in your mouth, but I'm imagining you simply really don't care what the worm is thinking, and the worm, conversely, has no clue that you consider yourself intelligent. You're just this thing that went by. So can you imagine a species that has such high intelligence that the prospect of communicating with us is simply of no interest to them?
Yeah, I can, yeah.
And they go by and their intelligence is on such a level that we can't even recognize it as intelligence.
Yes, and moreover, I think it would more or less have to be that much ahead of us if we were ever to meet them, because we're never going to get there.
Yeah, we sure as hell not getting there.
So
the NASA budget lately, it's not.
So anything that gets here has got to have a very, very highly developed technology, far more than we've.
That brings us to Stephen Hawking's concern about any civilization sufficiently advanced to visit us. What does that say about the consequence of that encounter?
Yeah.
And he's worried, of course, because he's taking his cue from the history of humans, with one has a more advanced technology than the other, and they visit. It almost is always bad for those with the lesser technology. And South America, one of the sort of more obvious examples in their first encounter with the Spaniards. So I don't know if I want to be the first one to shake hands, or shake whatever they're sticking forward. I don't know. I want to do it, but I still have my concerns.
What do you think are the odds that there is life elsewhere in the universe?
They must be high, and I'll tell you why. People say, well, have you found life yet? No. Well, that's like going to the ocean. This has been said before, taking a cup of water, scooping up, and saying, There are no whales in the ocean, you know? Here's my data, you know? You need a slightly bigger sample. And so if you look at, for example, what we call the radio bubble, this is the sphere around Earth, centered on Earth, which is the farthest our radio signals have reached in the galaxy. And they're about 70 light years away. We've been transmitting radio signals inadvertently leaking into space for about 70 years. 70 light year radius sphere. Well, how big is the galaxy? Well, shrink that sphere down to maybe the size of a BB, and then the galaxy on that scale would be the size of this stage. That's how far our radio signals have traveled. And those aren't even the ones we sent on purpose. The ones we sent on purpose have traveled much less. So no, we haven't actually reached as far into the galaxy as we'd like before we would say definitively that there's no one intelligent living today. But here's some very simple facts. I can review them in 90 seconds. You look at the formation of the Earth and the earliest sign of fossil life. Subtract a few hundred million years at the beginning of Earth, when Earth was a shooting gallery. Earth was still accreting the birth materials of the solar system. It's hostile to complex chemistry over that time. Not fair to start the clock then. Wait a couple of 100 million years. Now start the clock and wait around and see when you have the first signs of single-celled life. At most, 400 million years. At most. Earth has been around for 4.5 billion? So Earth, without any help from us, with basic ingredients found throughout the universe, managed to create life, simple though it was. So, and Earth, one of, 8 planets, get over it. One of, sorry. Earth, an ordinary star, to suggest, and what are the ingredients of life? The number 1 atom in your body is hydrogen. Number 2 atom is oxygen, together making mostly water that's in you. Next is carbon in this order. Next is nitrogen. Next is other stuff. My favorite element, other, yeah. You look in the universe, the number 1 element in the universe is hydrogen. Next is helium, chemically inert, couldn't do anything with it anyway. Next is carbon. I think I left out oxygen there. Next is oxygen. Next is nitrogen. 1 for 1. We're not even made of odd things. The most common things in the universe are found here on Earth, and we're made of them. And carbon, one of the most chemically fertile element on the periodic table. It's not a surprise. We're carbon-based. Life is just the extreme expression of complex chemistry. So that's what biology is. So all these people who want to imagine, because they remembered their chemistry class, that silicon sits right below carbon on the periodic table, so it bonds similarly to carbon, so they want to imagine silicon-based life. I'm saying, okay, fine, but you don't have to. There's 5 times as much carbon in the universe as silicon. There's no need to even have to go there. We got enough to imagine just simply with the carbon atom at the center of these huge biological molecules. Point is, it happened relatively quickly with the most common ingredients in the universe. To now say life on Earth is unique in the universe would be inexcusably egocentric.
Yeah, I agree with that.
Oh, okay.
And I would go further and say that if ever you meet somebody who wishes to claim that he believes or she believes that life is unique in the universe, then it would follow from that belief that the origin of life on this planet would have to be a quite stupefyingly rare and improbable event. And that would have the rather odd consequence that when chemists try to work out theories, models of the origin of life, what they should be looking for is a stupendously improbable theory, an implausible theory. If there was a plausible theory of the origin of life,
it wouldn't be it.
That's right, because then life would have to be
everywhere.
Everywhere.
Yeah.
Now maybe it is everywhere. My hunch is that there's lots and lots of life in the universe, but it's probably because the universe is so vast, the islands of life that there are are so spaced out that it's unlikely that any one of them will ever meet any other, which is rather sad.
It's sad. However, let me make you happy a little bit more from that. We've learned now that we can model the formation of the solar system. And this period of time where Earth was being bombarded heavily, that's called the period of heavy bombardment in the early universe. We call it like we see it in astrophysics. Let the record show. I don't know if I've ever in my life ever understood the title of a biology research paper. I just want to say that. Just the words, I'm not feeling them, you know? They're too big, too many syllables. I'm off topic here. So back to the period of heavy bombardment, and with computer simulations, you can model what happens when an impact hits a planetary surface. And it's not much different from if you sprinkle Cheerios on a bed, which you would never do on purpose, but your kids would do this. And then you smack the surface of the bed, there's a sort of a recoiling effect, and Cheerios pop upwards. It turns out Mars may have been wet, we know at some point it had water, and fertile for life before Earth. And at this period of heavy bombardment, if it had started life, surely it would have been simple life, there's no reason to think otherwise. We've learned that bacteria can be quite hardy, as you surely know. So we imagine a bacterial stowaway in the nooks and crannies of one of these rocks that are cast back into space. In fact, if you do the calculation, there's hundreds of tons of Mars rocks that should have fallen to Earth by now over the history of the solar system. Maybe one of those rocks carried life from Mars to Earth, seeding life on Earth. My great disappointment would be going to Mars and finding Mars life based on DNA.
Yeah.
Then it would not have been a separate experiment in life. We would just all simply have to get over the fact that we are Martian descendants.
What we need is a second sample of life. We have only one at present. And as
Why
you
have
say,
you only given us one?
It would be a disappointment, as you say, if we found life on Mars based on DNA. Well, at least if we found life on Mars based on the same DNA code.
Sure.
You just about imagine DNA evolving twice, but you couldn't imagine the same four-letter code evolving twice. So, but I wanted to make a point that your calculation of it took only about 400 million years at the most for the first life to arise. For the first life capable of broadcasting radio waves capable of being detected elsewhere in the universe, it took approximately just under 4 billion years.
Yeah.
About 4 billion years.
4 billion.
Which is about half the life that we can expect the solar system to exist.
Mm-hmm. An important point, by the way, because we were human before we had the technology to broadcast. So if your criterion for whether a planet has intelligent life, and if we are the measure of intelligence, then there could be plenty of planets out there with Roman empires and whatever else, and they're not sending radio signals. But any close enough observer would surely declare them to be intelligent.
The time interval between Roman empires and radio signals is negligible compared to the total time we're talking about. So it's an interesting question how long it takes once you get language, once you get civilization, once you get culture. How long does it take to get radio waves? Indeed, how long does it take to get self-destructive weapons that blow the whole lot up? I mean, that's the next.
And there's an implicit assumption that you're making inadvertently, possibly, that intelligence is an inevitable consequence of the evolutionary record. And I'm skeptical of that, because if that were the case, what we call our intelligence would have happened multiple times in the fossil record, and it hasn't. Whereas other things have shown up plenty of times, like the sense of sight and locomotion. There's some rather inventive ways things can get around the world. My favorite is the snake, of course. No arms, no legs, yet it gets around just fine. I'm imagining an alien visiting Earth, stumbling on a snake, the only creature it sees, right? And then it goes back and tells its home people, "You're not going to believe what I saw. There's a creature on that planet. No arms, no legs. It can still get around. It detects its prey with infrared rays and can eat things 5 times bigger than its head. And they'll think the guy was on drugs.
Yeah.
It's an ordinary snake sitting here on our Earth.
Yeah.
Another, just while I'm on the subject, big disappointment I have are Hollywood aliens. And I don't know who to blame for this, Hollywood or biologists that advise them. Hollywood aliens are way too anthropomorphic for me. Even E.T., he had a head, shoulders, arms. Okay, he had 3 fingers instead of 5. There's still fingers at the end of a hand. He had legs, he had feet. That's human. And look at the diversity of life on Earth to draw from if you want to think about the ways of being alive. I'm just so disappointed. And not even that I know that I can help them, but one of my favorite aliens ever was the Blob. Did you see that movie?
No, I don't see as many movies as you.
Blob is classic. It's just, so that alien was a blob, right? That's what it was. And it would just kind of move along and it would grab onto you and suck out your blood and keep moving. And it was non-anthropic in concept, and it came from space. And I just thought that was an attempt to try to create some kind of way of being alive.
That's a very laudable attempt. It is interesting to look around the animal kingdom and count up the number of times that some things have evolved. I mean, eyes several dozen times, ears quite a large number of times. Echolocation, that's finding your way around by sonar, only 4 times. So that's
a bat and who else?
A bat, whales, and 2 different groups of birds, cave-dwelling birds. And a few rudimentary examples in some shrews and sea lions, but really 4 different times. Intelligence and language of the humankind only once, as you pointed out.
So it can't be that important for survival.
Well,
if natural selection is at work, it should have shown up many more times.
You think so? But I mean, it's a genuinely interesting point that I think biologists haven't thought about enough, is to go around the animal kingdom counting up the number of separate arisings of something, because that does tell you something about what you might expect elsewhere in the universe. You'd expect eyes, you might expect echolocation, hypodermic syringes, stingers, about a couple of dozen. I'm talking about independent evolutions now. You look about spiders.
Our version of that would be called guns. Yeah.
Called what?
Our version of the hypodermic stinger would be called a gun.
Yes,
right?
okay.
You sting someone with
but I'm talking about something that penetrates the body and injects poison.
Yeah.
And that's an interesting question. And another relevant point is you look around the world at different island continents and say, how many times, how similar are they? You look at Australia, the Australian mammals, for example, and there are very, very powerful similarities between Australian mammals, which evolved entirely independently of mammals in South America, independently again of mammals in Asia and Africa. And so, again, that gives you a kind of a clue for how predictable evolution is. Other worlds are going to be very different, but we perhaps shouldn't write off the possibility that the Hollywood aliens are they might not be that unimaginative. I mean, my colleague Simon Conway Morris has even suggested that there is very likely that there will be, if not humans, at least bipedal, big-brained, language-toting, hand-toting, forward-looking eyes for stereoscopy, pretty much humans. He thinks it's highly likely. He's got a religious agenda, I'm sorry to say, for that. But like him, I appreciate the power of natural selection. I think that whatever...
By the way, I think if he were... if he were a creature other than a primate, he might be giving a different list of things.
I think that's
matter.
right. Yeah, I think that's probably right.
The horse doesn't have 2 eyes facing forward, but the horse damn near can see directly behind it, and so the horse would be valuing that fact.
Oh, I'm not denigrating horses at all. I mean, there are lots.
I'm just saying that's your first sign that there's bias. Is you start listing the human features that you would want in your alien.
I don't want to say that I'm not picking on humans because they're superior, but because they're us. I mean, we have stereoscopic vision, we have 3-dimensional vision, horses don't. They have a different kind of vision, insects have a different kind of vision. Bats have echo. I mean, it's not vision, but it's using sound to produce what I would guess inside the bat's brain is probably perceived rather the same way we perceive visually, because why wouldn't you use the tools of the brain, of the mammalian brain,
To create an image.
to create a model of the world. I've even speculated
By the way, that they showed that in, forgive me, the movie Daredevil.
do they have
He's blind, and when it rains, he likes when it rains because the rain hits people and he hears the different sort of reflections of the sound, and he saw his girlfriend for the first time in the rain. There's the image of her.
Okay, but my speculation is that bats hear in
It's
colour.
America. I got to talk about our movies here. Sorry.
My speculation is that bats hear in colour. Because why wouldn't you use colour? Colour is just hue, perceived hue, is nothing more than a label that the brain uses.
Precisely. That's all it is.
Yeah.
Color, you attach it to some
You
sequence
attach it
of
to something.
changed
And
phenomena.
so bats would most usefully use colour as a sign. For example, the difference between a furry moth and a leathery locust might be perceived as red versus blue.
Mm-hmm.
And that would be a very useful way for natural selection to have tied the labels of hue onto something that would seem very strange to us. But we're coming to the end of our time.
Didn't we just begin like a second
Well, that's
ago?
rather what I felt. If we want to have some time for questions...
Which I would very much like that, but I had a couple more bones to pick with you.
Okay, well, let's go quickly through those bones.
Okay. And just if you start formulating questions in your head. Some years, actually, 1994, was it? Or 1996, there was this rock in Antarctica, a meteorite discovered, ALH 84001, which had tantalizing evidence. By the way, that rock was from Mars, one of the tonnage of rocks that we know are out there. And there was evidence in one of the nooks of that rock for possible life, traceable not to Earth but from Mars. And so the evidence was very circumstantial, but interesting nonetheless. There was chemistry there that could only happen in the presence of oxygen, and there was chemistry there occupying a similar spot that could happen only in the absence of oxygen. Now you might say, well, who cares? Well, life is just such a machine. When you breathe in oxygen, you oxygenate the hemoglobin. That oxygen gets used for your metabolism, and it goes back without the oxygen. In your same body, you have oxygenating and deoxygenating forces operating within you. So life does it for free. If you don't appeal to life, you'd have to have the rock hang out over here for a while and then roll down a cliff and go anaerobic for a while. You'd have to sort of patch it together. So it was all the news, page one story. And they even had an electron microscope photo of what looked like an itty-bitty worm. It had little segments on it. It was intriguing. That was not the lead evidence of the authors. It was just kind of interesting. It was about 1/10 the size of like the smallest worms on Earth, but interesting nonetheless. I'm invited to comment on this. In fact, it was Charlie Rose. He had 4 people. I'm the astrophysicist. They had a biologist. They had a philosopher. And the picture of the worm comes up. The biologist, who was piped in by a screen, said, "That can't possibly be life." So I said, wow, what have I missed? So tell me, sir, why is that good? Oh, because the smallest life on Earth is 10 times that size. And I'm still waiting for him to give me the reason why it can't be life. Then I paused and reflected and said, well, that is the reason he's giving me, that it can't be life. His comparison with life on Earth. And then I said, last I checked, we're talking about a rock from Mars. Why are you using Earth to constrain your capacity to think about what exists out there? My question to you, are biologists closed-minded or open-minded about what is possible in terms of biology in this universe? Because at the end of the day, you go behind closed doors and you confess to yourselves that you only have a data sample of 1. Because all life on Earth has common DNA.
Yeah. Well, he was being
and most any other sciences, we would say that's not. How do you make science out of a sample of 1?
No, that's right. He was being closed-minded. No question about it, because he was using his experience of life on this planet to make that generalization. On the other hand, one could make such a statement by using the laws of physics, and you could say that there are certain things that wouldn't work for physical reasons. I mean, I'm not saying that a tiny worm wouldn't work for physical reasons, but I could imagine somebody making an argument that said you cannot have, for example, maybe there's a certain minimum size of eye that could form an image for purely physical reasons. And that would be a good reason why one might.
And I'm there all the way.
Yeah.
It's just that he cited Earth as his measure of what is possible.
Well, he was just wrong.
Okay. Okay. You don't align yourself with his
I don't know who it was, but
that was the biggest thing I had to get off my chest here.
Okay. Shall we bring up the lights and see if there are...
There are microphones in the aisles, apparently, so if you just line up in the two center aisles behind those microphones, and I guess we can pick left and right for what questions you might have.
Professor Dawkins, we're very pleased to hear that you're writing a children's book on the beauty of science. We'd like both of you to write one for adults, or a video special on TV, because we don't want this wonder and awe that you all have been discussing today to be co-opted by religious people in the world, and it is really wonderful. So what can we do to spread the word that science is not something to be afraid of, it's something to really be in wonder of?
Right.
Can I just slip in there? You commented that the book there's a children's book where you need one for adults. Indeed, we need one of those for adults. Interestingly, we probably don't need it for children, because children are born inquisitors of their natural world. They turn over rocks, they jump in puddles, they pour water down your back. They do things that are, you can look at it as wreaking havoc in the house, or you can look at it as a long series of science experiments. Some of them gone playfully wrong, but nonetheless explorations into the natural world. What happens is over time that gets beaten out of them, because that is not the behavior of the sign of obedience. That's the behavior of disarray. And plus adults far outnumber children. So I think the real problem in the world is adults, especially since they control the world, not the kids.
Yeah. I mean, what I would say about how we're going to convey the wonder, which you and I are both extremely interested in doing that, and following your mentor, Carl Sagan, for example. I mean, I like to make a distinction between what I call these two schools of why we should pursue the space race, space exploration. The non-stick frying pan way, which is it's useful because you get spin-offs like non-stick frying pans, and it's wonderful. And I go for the wonderful part, and I find that one of the problems with people who attempt to convey science to lay people, whether it's children or adults, is they tend to be obsessed with bringing it down to earth and making it ordinary and mundane and the sort of thing you might meet in your own kitchen. I prefer, and I'm glad somebody's doing that, but for me, I prefer the wide open spaces of space, the wonder of looking down a microscope at the very small, and thinking about it from a sort of from a more poetic point of view rather than from a more utilitarian point of view.
Right here, yes.
Hi. First, I'd like to say thank you. This is very stimulating, and it's wonderful to have this here at Crampton University, at Howard University, Crampton Auditorium at Howard University. I have a practical application question for technology and its impact on humans, specifically cell phones, cellular cell phones. I'm in healthcare, and I'd like to know where you stand on the effects. And I know we've come a long way since the first cell phones came out, but I get particularly apprehensive when I see young people putting cell phones to the heads of little infants and saying, "Talk to daddy," or something like that. That's my first question, the impact of the waves and things like that, which is out. I know I've looked at some studies on human beings. And then my second question is about the references for the origins of calculus in the Egyptian culture. Thank you.
Okay, given how many people are in line, I think we should try to answer as quickly as possible to do this. And I'll take a first stab, and if you want to try that as well. I don't know of any first efforts at calculus in the Egyptian culture. Perhaps Richard does. And with regard to cell phone use, there's a very important fact of science, and that is the act of measurement. It's a fascinating thing, measurement, because You can never measure anything precisely, that is, with unlimited precision. You can only measure it with the uncertainties of your measuring device. And all you can do in the lab is try to constrain how uncertain that measurement is, but at some level it will always be uncertain. And here's what happens. If you're trying to measure a phenomenon that does not exist, the variations in your measurement will occasionally give you a positive signal, as well as a negative signal. If that positive signal is the idea that maybe A causes B, in this case, cell phones cause cancer, a paper gets written about that result, and then people get concerned that cell phones might cause cancer or power lines might cause cancer. This goes way back. And so, in fact, if you look at the full spate of these studies, even those that they thought not to publish because it was not a positive effect, there's some cases where, in fact, there's less cancer. And so these are the phenomenon of a no result. When you actually have A causing B, the signal is huge. It is huge and it's repeatable in time and in place. With cell phones, that repeatable signal is yet to emerge from the total experiments that are done on it. That being said, if you're worried, almost every cell phone they have the cell phones on your hip and you've got an earpiece. So just do that if you're worried. But otherwise, I can either say the jury is still out or the experimental results are consistent with no effect at all.
I have nothing to add to that.
Okay.
About the
Sir.
calculus in Egypt.
So, can we have this one now?
Yeah.
Please?
Yes, I was interested when you were speaking about the bubble of radio waves as far as the limitation of our communication. I've read recently at the Large Hadron Collider, they've had some crazy experiments, but there are apparently particles that are seemingly unconnected, but they react to each other in symmetrical patterns of some kind. I'm very amateurish on this. But what do you think would be the possibility of instantaneous communication across vast distances using some kind of particle manipulation?
Yeah,
That's exactly it's exactly an example of the kind of thing I meant when I said it's beyond me.
Yeah, so quantum physics is the physics of the world of the small. And in fact, quantum rules apply macroscopically, but they don't reveal themselves as exotically as what happens with single particles. And a particle can pop into existence, go out of existence, what we call tunnel from one place to another, instantly, with no time delay between the two. It could exist in all places at once and then show up instantaneously here when you make the measurement. These are quantum rules that don't make any sense to us because we don't live in a quantum world. If we did, these would be phenomena that would be quite natural. So now, can we exploit the quantum world for faster than light communication is what you are suggesting here. And there's no known way to do that given the laws of physics. In other words, you can have what's called a wave form, a wave function of a particle, and it's everywhere. You make a measurement, then the particle instantly shows up here, even though the wave had a probability of existing, the particle had a probability of existing over here. And so it's just odd, and we don't know how to exploit that fact to our advantage. But as far as we know, no, you cannot have faster than light communication, which we would desperately need to get bigger than the bubble to talk to the rest of the galaxy. Again, I'll try to make my answers even shorter than that. Yes, sir.
Making the distinction between life in the universe, which I think is inevitable, and intelligent life in the universe, which is, I question or challenge at least, the probability of, given our planet being in the right location, the star being in the right type of star, in the right location, etc. What are the odds that you would, and given the time it took, 4.5 billion, 4.6 billion years, for us to get to the point where we can ask the question, is there intelligent life in the universe? What do you think those odds are?
The universe is huge in time and in space and in contents. So the good thing about the universe is extraordinarily rare phenomena happen every day, someplace in the universe. And so however rare we might calculate it would be up here for life as we know it, you multiply up the numbers, stars in the galaxies, galaxies in the universe, these are staggeringly huge numbers, 10 to the 21 stars, 1,000 times bigger than the number of grains of sand on an average beach. Itself 100 times bigger than the number of words ever spoken or uttered by all humans who have ever lived. These are staggeringly large, stupendously large numbers, to use Richard's word, that give us the confidence that even if intelligent life is only short-lived, grows up and then it becomes so smart it can kill itself, that there's bound to be one out there that we're hitting it right at the right time, that they are happy to have a conversation with us if we're smart enough to have a conversation with them.
This question is primarily for Professor Dawkins. I come from a family where there are 2 skeptics and 3 religious fruitcakes. You can guess which side I'm on. Anyhow, I was just wondering, with your experience, if you've ever found a good way to hit the fruitcakes upside the head with some rational thinking and actually get them to pay attention.
It would be nice to say that all we need to do is to expose them to scientific evidence. And that's certainly a very important part of it, is what Neil and I are both trying to do. Unfortunately, there's a certain amount of evidence that there's a certain kind of mind which is so dyed-in-the-wool, wedded to a scriptural version of the world that they more or less admit in advance that no matter what evidence comes, they will refuse to budge. I mean, a good example, my favorite example of this is the geologist Kurt Wise, who is a young Earth creationist, but who knows very well all the evidence for an old Earth from geology. And he has actually said in these very words, I think I quote him approximately right, if all the evidence in the universe pointed to an old Earth, I would be the first to recognize the evidence, but I would still be a young Earth creationist because that is what Holy Scripture tells me. Somebody who's actually prepared to come out and say that, at least he's honest, somebody who actually comes out and says that is pretty much advertising himself as beyond reason. He's absented himself from the rational discussion which the rest of us are having by announcing in advance that Scripture is going to take precedence over evidence. And here's a man who knows the evidence. He has a PhD from Harvard in geology. He knows the evidence, and yet he's announced in advance. So there are certain people who are unreachable, but my hope is that the vast majority of people are eminently reachable and just simply haven't been exposed to the evidence which is plentiful and wonderful.
Next question here.
Thanks for the great job on the poetry of science. I wonder if you could say just a few words, both of you, on the philosophy of science. Just read Stephen Hawking's book, The Grand Design. First page, philosophy is dead. And here at Howard, our administration is proposing the abolition of our philosophy programs. Could you say a few words?
I have a couple of words to say about that. Up until early 20th century, philosophers had material contributions to make to the physical sciences. Pretty much after quantum mechanics, remember the philosopher is the would-be scientist but without a laboratory, right? And so what happens is the 1920s come in, we learn about the expanding universe in the same decade as we learn about quantum physics, each of which falls so far out of what you can deduce from your armchair that the whole community of philosophers that previously had added materially to the thinking of the physical scientists were rendered essentially obsolete at that point. And I've yet to see a contribution. This will get me in trouble with all manner of philosophers, but I call me later and correct me if you think if I missed somebody here. But philosophy has basically parted ways from the frontier of the physical sciences. When there was a day when they were one and the same. Isaac Newton was a natural philosopher. The word physicist didn't even exist in any important way back then. So I'm disappointed because there's a lot of brain power there that might have otherwise contributed mightily, but today simply does not. Philosophy has it's not that there can't be other philosophical subjects. There's religious philosophy and ethical philosophy and political philosophy, plenty of stuff for the philosopher to do, but the frontier of the physical sciences does not appear to be among them.
Even in biology, I think is an interesting point that the idea of evolution by natural selection, which came independently to two traveling naturalists in the 19th century, it's a simple enough idea that any philosopher could have thought of it from the depths of an armchair anyway back to the Greeks, and none of them did. And I don't really understand that. It seems to me to be a strange thing that it had to wait for two 19th century scientists living 200 years after Newton did something that seemed a lot more difficult.
Well, check Anaxagoras.
Sorry?
Check Anaxagoras, first theory of evolution in pre-Socratic Greeks.
Oh, well, okay. But natural selection is something that came in the 19th, not just to Darwin and Wallace. I mean, there were a couple of other scientists who thought of it. The philosophers that I really respect in the world today, philosophers of science, are ones who've actually taken the trouble to learn some science, and there are some, and they're very good, clear thinkers, and they do help other people to think clearly. But they're really the same as scientists. I mean, they're scientists who are also trained in philosophy.
Sir.
Thank you both for coming. There's a group of scientists in Europe that have developed a Large Hadron Collider, and they're trying to recreate the conditions of what has been known as the Big Bang, slamming antiprotons and protons together to try and find a particle known as the Higgs boson, which has been misnamed the God particle. It's a particle that gives matter mass. Could you guys talk about the conditions of the universe at that time? Will this prove anything, this experiment?
The interesting thing about physics is that there's very little physics left to be discovered on a tabletop. The way physics works is, the way discoveries in physics, by and large, work is, you need to go someplace you've never been before, either in scale, large, small, energy especially, speed. Once you explore these extremes, you are at the hairy, bleeding edge between what is known and unknown in the universe. So, if you want to discover something you've never done before, build an accelerator that hits an energy level that's never been hit before. And the early universe is our best particle accelerator we know. And so now we have the very large tabletop version of the early universe, large and expensive, and it now allows us to test our ideas about what was going on. And so, yes, it's a regime of the early universe that we have theoretical understanding of, but we yet to have experimental verification for it.
I have visited the Large Hadron Collider twice. And on both occasions, I was more or less literally reduced to tears. I was moved so much by this stupendous effort of human ingenuity, human cooperation, multinational. And I expressed attempted to express my poetic fascination and interest in this terrific enterprise in my latest book. And there was an unfortunate misprint. It came out as the Large Hard-On Collider.
That's just the D and the R, right? I guess that's...
I spotted the misprint, and of course I left it in, but alas, the publisher's proofreader also spotted it. She removed it. I begged her on my knees to leave it in. She said it was more than her job was worth.
It's a quick social comment. The 1990s canceled superconducting super collider that was to be built in Texas had peak energies 3 times as large as the Large Hadron Collider in Switzerland. Congress voted to not continue its funding. The project was scrapped, and now the center of mass of particle physics is no longer in the United States, it's in Europe. Now, interesting to the scientists, why we'd rather it be here in America, we really celebrate the fact that science continues to advance, and it's just a matter of whose nation's priorities values it. And I saw that as the beginning of the end of America's leadership in this realm.
Thank you.
All right, thank you so much. I probably have a question which is rather mundane in this setting, but one doesn't get these opportunities very often. I recently thought about this. The life that's been discovered at the point of seafloor spreading on Earth is, I assume, because I haven't heard otherwise, also DNA-based, as is everything else we know of. And my curiosity is whether there is a hypothesis or an explanation that has been in fact devised as to how DNA can have this effect over the distance of 5,000 or 6,000 miles in the ocean itself between that point and the surface.
Not miles in the ocean. I mean, the diameter of the Earth is only 8, you mean feet down?
I'm sorry.
Yeah, just the ocean bottom.
5 or 6 miles.
Yeah, thank you. You said 1,000.
Exclude the 1,000.
Okay. I can give an astrophysicist view, but I'd welcome the biologist.
I didn't actually hear the question, so you start off by...
Sure. So these extremophiles, these are creatures that thrive under conditions that would kill the rest of us instantly. Under high pressure, high temperature. In fact, at the ocean vents, they're thriving at 300 degrees Fahrenheit. The pressure of the water is high enough to prevent boiling, but the temperature is high enough that it would cook anything else. One of the great advances in exobiology was the discovery that life on Earth is hardier than anyone had ever previously given it credit. We no longer need the room temperature pond water to have life thrive. The more we've looked in the Earth, the more we've found life doing the backstroke under extraordinarily hostile conditions, hostile to humans, that is. What that has done for us astrophysically is allow us to cast for life with a much wider net than we had previously thought we had available to us. Whereas before we would look in the habitable zone, the Goldilocks zone, not too close to a host star, your water would evaporate, not too far away, water freezes. You're looking for that liquid water zone, made liquid by sunlight. We find out all you really need is an energy source, doesn't have to be the sun. Jupiter keeps Europa warm, one of its moons. It has a liquid ocean, it's been liquid for billions of years. You want to look for life, armed with this diversity of life, the hardiness of life, even we find here on Earth, it has only broadened our search for life in the cosmos.
Among the many theories of the origin of life, recently people have started thinking about life might possibly have started under what we now think of as extreme conditions of high temperature. And it could be that we are now in the cold zone, which was not the way it was when it first started, and that's an interesting possibility.
So they would look at us like we're the extremophiles.
Exactly. They look at us as though we're the extremophiles.
I'd like to ask my question.
Well, my department chairman has said that he wants you to go ahead and ask your question. I'm not going to tell him no. So please ask your question. Keep it brief, and this is the last one before we go on to the book signing.
Thank you, Howard, for making this free. Anyway, I read a book, Constellation of Philosophy. The main guy, Boethius, is condemned to death. He has everything taken from him. All he has is his reason and his sense of self. Not even that. But he attempts to console himself to this execution by reasoning that the world has order, that there is something that keeps things together. And he uses his reason to try and get to the root of why he should be at peace at death. The problem is, his source of origin is a belief in God. What would you do?
Well, I don't know if I fully understand the question. I do know that if he's about to be executed...
How about you are about to be executed?
Oh, I'm about to be executed.
You have nothing except your knowledge and your knowledge of science, your experience.
I would request that my body, in death, be buried, not cremated, so that the energy content contained within it gets returned to the earth so that flora and fauna can dine upon it, just as I have dined upon flora and fauna throughout my life.
What about you, Mr. Dawkins?
And I'm sorry, we have to move on. Please, another round of applause for Professor Dawkins and Dr. Tyson.
you want me to sign this?
Yeah. Oh, sure. I mean, you can look at it too.
Truly you.
The next year when I wasn't 60 anymore.
No.
Thank you.